Welcome to today's video, where we will be looking at how to approach unfamiliar functions when facing the GRE Math Subject Test. My name is Mohammed Omar, and I'm a professor in the Math Department at Harvey Mudd College. Today's problem is, for any real number x, let bracket x bracket be the greatest integer less than or equal to x. For example, this function applied to 3.7 is 3 and to 7 is 7. Evaluate the integral from 1 to infinity e to the negative bracket x bracket dx. Now on the GRE Math Subject Test, it's natural to feel uncomfortable with a question that has an unfamiliar function in it. But don't panic, brave the function. Our approach will be to dissect this unfamiliar function first in order to address the problem at hand. This function is actually called the floor function in mathematics, so we will refer to it as such for the rest of the video. First, let's understand how to compute the floor of x for any given real number x. The function floor of x only takes on integer values, and the floor of x is n precisely when n is less than or equal to x, and x is strictly less than n plus 1. So we can use this information to dissect the integral in our question into pieces we can integrate much more easily. So now we split the integral into a sum of integrals. The integral from 1 to 2, the integral from 2 to 3, the integral from 3 to 4, etc. And the reason for doing this is because the floor function is constant in the interval 1, 2, and the interval 2, 3, and the interval 3, 4, etc. So this will make integration easier. The value of the floor of x in the interval 1, 2 is 1. In the interval 2, 3 is 2, in the interval 3, 4 is 3, etc. And so we can rewrite our integral as the sum of the integral from 1 to 2 of e to the negative 1 dx, plus the integral from 2 to 3 of e to the negative 2 dx, plus the integral from 3 to 4 of e to the negative 3 dx, etc. Now all the functions that we're integrating are constants, right? And so we can multiply the constants we are integrating by the length of the integrals we're integrating over. But all these intervals have length 1. And so our integral is the sum e to the negative 1 plus e to the negative 2 plus e to the negative 3, etc. So now we've deduced that the integral we're interested in is the sum e to the negative 1 plus e to the negative 2 plus e to the negative 3, etc. We can write that as 1 over e plus 1 over e squared plus 1 over e cubed, etc. If we factor out the 1 over e, we're left with 1 over e times the geometric series 1 plus 1 over e plus 1 over e squared, etc. The geometric series in the parentheses has common ratio 1 over e and is infinite with first term 1. And so its sum is 1 over 1 minus 1 over e. And if we collect everything and simplify, we're left with 1 over the quantity e minus 1. Thank you for watching today's video. If you liked it, please click the like button, and if you're interested in seeing more videos like this, please subscribe to the channel.